So in question 2, same idea as question 1, but now we have variables. And if we read the question, take out my highlighter, identify where it's defined, then expand and simplify. So we have 2 things that we have to do in this question. We have to say where something is defined, and we also have to say and simplify and expand. So first of all, define. We're not allowed to take square roots of negatives. Do we have square roots? Yes. Do we have a variable inside that square root? Yes. Can you see that if b is negative, it would be bad? So it is defined when b is bigger than or equal to 0. If I have 2 binomials multiply by each other, I would FOIL this out. So I'll draw my arrows. 7 times 3, 21. 7 times a negative 5 root b, well, the numbers get multiplied, so that'll be negative 35. The radicals get multiplied, but there's just the one of them, so it just stays root b. 2 times 3 would be plus 6, and the radical stays root b. And finally, 2 times a negative 5, negative 10. And root b times root b would be root b squared, which would normally be the absolute value of b. But since we've already defined b to be positive, we can just write b. Whew. That little detail of the absolute value is like, kind of makes you think. So now do we have any like terms? Yes, we do. The negative 35 and the 6. We can combine those like terms and put everything together. Now nothing is alike. This would be our final answer. Expanded, no more brackets. Simplified, none of these are like terms, and none of my radicals can be reduced to the simplest form as a mixed radical. I can tell you right away, as soon as there's a subtraction sign, mistakes go way up. So I'm going to just tell you to be careful with that subtraction sign. Again, one of the best ways to be careful is to take your time. Okay. The first one, the first set of brackets that are together, and I'm going to put those, maybe, I'm going to put the first set in one set of big brackets, and I'm going to subtract, and I'm going to put the second one in another big set of brackets. We can keep brackets. It's often good to keep brackets for a while, especially with that subtraction sign, because that subtraction sign where I wrote careful means you're subtracting all of this. So even if you expand it, you still have to subtract all of it. And that negative sign is going to get distributed in the end, which is the number one mistake students make in that they forget. The first one, if you recognize it as a difference of squares, it'll be this one squared minus that one squared. So you could use the shortcut. You could also use all the arrows. It would not be that. The second one, I actually take my time anytime something is squared. I take my time and I rewrite it plus 5 root y and square root of x plus 5 root y. I rewrite it because I am going to have to, when something is squared, multiply everything. Common mistake that students do when they square something is they just decide, oh, I'll just square the first one and square the second one. And then you would get that wrong. So I'm going to do inside of these square brackets as much as I can first, and then worry about the subtraction afterwards. So this is going to be, oh, we never did define. Maybe I will shift this up a little bit and add that in. Do we have any square roots in B? We do. We have square root of x and square root of y. Can you see that it's only defined when x is positive and when y is positive? So I square the first one, this will be 9, and it will be x, and I can just write x, not the absolute value, because I've already defined x to be positive. The second one, when I square it, will just be minus y. Root x times root x is x. Root x times a 5 root y will be plus 5 root x y. And then I have another plus 5 root x y. And then 5 times 5 is 25. And root y times root y will just be y. The first set, 9x minus y. I don't need the brackets there anymore. There's nothing that I'm worried about there. I do see that I can simplify a little bit in these brackets, so I'm going to do that first. X plus 10 root xy plus 25y. Now this negative, this subtraction, those brackets are important there because you're subtracting all of it, meaning that negative goes to each one of those. So I'm going to get a 9x subtract 1x. If I combine those like terms, can you see that it will give you an 8x? You will have a minus y minus another 25y's. That'll give me minus 26y. And this negative gets distributed to this as well. Now I have no like terms to combine together. No brackets are left. My radical is in lowest terms. This is considered simplified completely. And expanded because there's no more brackets. All right, circle question 8.